I'm going to show you an experiment here with 3 different double slits. The experimental setup is going to be the same, except I am going to switch out the double slits that I'm going to use at this position. So the experimental setup is basically a Michelson interferometer. One arm is here, and this arm is going to be polarized in the vertical direction. This arm here is going to be the horizontal direction, so perpendicular polarization in each arm of this interferometer. To start with, we have a 639 nanometer 5 milliwatt laser, followed by a quarter wave plate, which gets the polarization circular or elliptical, so that it will be optimized for interacting with these linear polarizers. This is just a mirror. This is a 50-50 beam splitting mirror, non-polarizing. So half of the intensity of this laser will go to this arm, half will go to this arm. As I said, this arm is vertically has a linear vertical polarizer right here in this mount. This is a mirror, and this is a horizontal linear polarizer in this mount. This is a mirror, and here's our double slit. To start with, I have just an unmodified double slit purchased from Thorlab, and down at the other end, I have my camera, and I'll put that in as inset to this video, so you can see the interference pattern. So right now you're seeing a double slit interference pattern, and this experiment, the novel part of this is I'm going to rotate this double slit. And so we're starting now at with the double slit pattern being horizontal. We'll take it through a full 180 degrees. And you'll notice at every point in this rotation, the double slit pattern remains. And then I'm going to block just one arm of this interferometer. So now only vertically polarized light is interacting with this double slit, and I'll go another 180 degrees. And while the result is less intense, the double slit pattern stays through the entire 180 degree rotation. All right, I'm going to pause the video and switch out my double slit. The only change I've made is to put a vertical oriented polarizing film in front of this slit and a horizontally oriented polarizing film in front of this slit. And otherwise the setup is the same. So here we are at 0 degrees, and you can see there is a single slit interference pattern as you expect for the classic marked double slit experiment. Now I'm going to rotate to 45 degrees. Still single slit pattern, and I will continue through a full 180 degrees. There we go, back to 180. So single slit interference pattern throughout the entire rotation. Now I'll block one arm of the interferometer, and I'll do another 180 degree rotation. And you'll notice the single slit pattern remains throughout the entire rotation. I'm going to pause and switch out the double slit. Now it's time for the Young Inquisitor. About 2 days have passed since the last 2 double slits were done on this bench. I rebuilt the Young Inquisitor about 3 or 4 times. I just wasn't satisfied with how clean and how lined up the polarizing and half-wave plate filters were. But now I'm happy. I feel like I've got it as good as I can. So otherwise, actually I did switch out the camera. So this is the camera that is recording this bench is actually the camera that was inset before. I put my better camera now for the inset, so that double slit interference patterns can more easily be seen. But otherwise, the setup is the same. The laser, 45 degree linear polarizer, a 90 degree, so horizontal linear polarizer, and a vertical 0 degree linear polarizer. This is the Young Inquisitor, so Young Inquisitor is a double slit on this just covering this slit here is a vertical linear polarizing filter, just covering this slit here is a horizontal linear polarizing filter. And on the back side of only this slit, the vertical slit, is a half-wave plate which retards the light and rotates the polarization so that coming out the back, we just have horizontal light coming out the back. And then it's projecting onto the wall where you'll see the inset view. All right, I'm going to turn off the light. Right now I've got it set at 0 degrees, and you can see that there is a double slit interference pattern when both of these arms are open. If I close one arm, you get a single slit pattern. Close the other arm, single slit pattern. Now, here's where the Young Inquisitor gets even more interesting. When you go to 45 degrees, you'll see that there is a double slit interference pattern, and when I close one, you still have a double slit pattern, and when I close the other, you still have a double slit pattern. So that's the key phenomenon of the Young Inquisitor, is the performance difference at 0 degrees and 45 degrees, and at 90 degrees the performance will be the same as at 0 degrees. So right now you should be seeing a double slit pattern. If I block one arm, should go to single slit, double slit, single slit. And we can continue to the negative 45 degree angle. And here you should be seeing a double slit interference pattern. And I block one, you still have a double slit. Block the other, still have a double slit. That's all. Thanks. These are the two double slits I used. On the left is the unmarked double slit. On the right is the Young Inquisitor. The unmarked on the left, when I made it a marked without the half-wave plate on the backside, I just moved this over the double slit. So the Young Inquisitor with the half-wave plate, it's a membrane. You can see it there on the back surface of just one slit. It's an adhesive membrane. All right, and Parker and I noticed something interesting. You can try to create a pseudo single slit pattern. So here we have the Michelson interferometer set up, negative 45 degrees linear polarizer, 45 degree linear polarizer, and this is an unmarked double slit there. You can see the interference pattern on the inset. Parker's down by the inset to help me get this lined up just right. So first I'm going to take it out of alignment, and now...
You can move it down a little bit.
Down that way a little more?
Yeah, down. Wait, you're moving up.
Oh, sorry.
Oh wait, okay, that's good.
And now we want to try to get them so they... Do you want me to go this way a little bit?
Left towards
okay. Am I going left when I do this?
No.
Other way?
Yeah, right there.
Now
go up a little bit.
Up a little bit?
You're going down.
Thanks, bud.
To the left a little bit more. That's the right. Keep going left. Keep going right there. And then go up. Right. Stop. Okay.
Is it pretty good?
Yeah.
I want to come see it.
I think you can move it a little bit more to the left if you want.
Let's try to get even better.
And move it a little bit to the left.
I'm going the wrong way?
I think.
No, I'm going the other way.
Mm-hmm. Keep going that way. Keep going. Right there.
Is that good?
Oh, a little bit more.
Okay.
Right there.
It's still, yeah, Yeah, I know, it's still there. I'm just attenuating it with I'm putting another linear polarizer. Maybe it looks more like a double slit when we've got the background lights on.
Oh, maybe that's why we saw it better before. Oh yeah, now that just looks like a line.
Now it just looks like a line?
Yeah.
Pretty close. So the point is that in order to create this pseudo single slit pattern, you actually need to take the lasers, or the two arms of the Michelson interferometer, out of alignment. So if I remove this double slit, you can see the two dots of the laser. Let me try to attenuate it with a polarizing film here. I can't attenuate it enough for you. Oh, wait, maybe. Oh, that just even removed one dot. Well, the two dots are approximately from center off by 4 to 5 millimeters. So in order to create a pseudo single slit interference pattern, there actually needs to be a physical misalignment in the system.